Breathe in, and let the noise of the day drift quietly away. Tonight, we journey through the stillness into a universe that does not begin or end, but flows in perfect, endless motion. Time softens here, curving gently like light across a distant horizon. The stars whisper their ancient secrets, and the fabric of space hums with the quiet pulse of being. This is a story not of endings, but of continuation, of the hidden symmetries that shape existence, the unseen geometry beneath creation itself. Together we'll wander through Hawking's timeless universe, the restless hum of the quantum vacuum, and the shimmering possibility that reality might be both dream and design. Let each thought unfold slowly, like a wave returning to shore. Let curiosity guide you deeper into calm, and wonder remind you that even in silence, the universe speaks. The cosmos has no before, no after, only this moment, vast and luminous, waiting for you to drift inside. There are questions so vast, so beautifully impossible, that even to ask them feels like standing on the edge of creation. One of them begins like a whisper at the back of every curious mind. What existed before the Big Bang? It's a question that folds in on itself, an echo, chasing a sound that might never have begun. The words are simple enough, yet hidden within them is a paradox that bends both logic and imagination. Because if time itself was born with the universe, then before may not exist at all. To wonder about before the Big Bang is to wonder about a place without distance, a moment without time, a cause without causality. The human mind, so deeply anchored to clocks and calendars, can barely hold the shape of such emptiness. We are creatures of sequence and story. Our thoughts move forward. Our language has beginnings and endings. Yet in this question, both dissolve. It is as though we are asking what lies north of the North Pole, a direction that exists only when there is somewhere left to go. Physicists call this the cosmic singularity, the boundary where space-time and the laws of physics as we know them break down. General relativity. Einstein's grand description of how matter tells space to curve and space tells matter how to move predicts that all of the matter energy and even the fabric of space itself once converged into a point of infinite density. In that instant, if we can even call it an instant, the equations that describe the universe stop working. Numbers lose meaning. The predictable harmony of mathematics collapses into silence. And yet within that silence lies everything we are. Every atom in your body, every color of every star, every thought that has ever crossed a human mind, all trace their ancestry to that unimaginable compression. It is not just the beginning of the universe. It is the beginning of possibility. To visualize it is impossible, but we try. Imagine the night sky shrinking, every galaxy folding inward until light itself cannot escape the convergence. The vastness, you know, hundreds of billions of galaxies, each containing hundreds of billions of stars compressed into something smaller than a grain of sand. This is not an explosion in space. It is the expansion of space itself, the stretching of the very coordinates that define location. The Big Bang was not a detonation in the dark. It was the dawn of dimension. And yet the question remains, if time began here, what set it in motion? Did something ignite the universe? Was there a trigger, a spark, a breath before the first expansion? Our intuition demands it because in our everyday experience, nothing begins without a cause. A flame requires fuel. A river begins at a spring. But what if the universe is the spring? What if causality itself was born in that same cosmic instant? Einstein once said that time and space are modes by which we think, not conditions in which we live. This idea takes on a haunting beauty. when applied to the beginning of everything. Before the Big Bang, there was no before. There was no where. Only potential, the silent readiness for existence. For generations, cosmologists have tried to peer through that veil. Their tools are light and gravity observation and mathematics theory and imagination. We can trace the history of the universe back to a fraction of a second after the Big Bang, to a moment known as the Planck era, when the entire cosmos was less than 1/10 trillion trillionth of a second old. Beyond that, the physics we know dissolves. Quantum uncertainty rules the landscape. The very concept of time passing no longer applies. It is here, in this twilight, between knowledge and mystery, that science becomes poetry. The equations stop speaking, but the silence is not empty. It hums with the promise of deeper understanding. Imagine drifting through that silence, not a void, but a stillness, full of potential. There is no light yet, no heat, no direction. Only the curve of possibility folded within itself, like a seed before it breaks the soil. In that nothingness, time is sleeping. Space is unborn. The future, the past, the endless now, all are one. And yet somehow from this infinite compression, something moved. A whisper of expansion, the smallest tremor of energy rippled through the void. Within less than a trillionth of a second, the universe leapt outward in a frenzy of creation space, stretching faster than light, carrying with it the blueprint for everything that would ever exist. But what caused that first motion? Science, at least for now, offers no certain answer. Some physicists suggest it was a quantum fluctuation, a spontaneous event permitted by the uncertainty of quantum mechanics. Others propose that our universe is one bubble in an eternal cosmic sea, where universes constantly blink into and out of existence. Still others wonder if time itself is cyclical, if our Big Bang is not the first, but merely the latest breath of a universe that has always been. To contemplate these ideas is to feel the limits of human comprehension stretching like the skin of space itself. But perhaps that is the purpose of such questions, not to reach definitive answers, but to remember the wonder of not knowing. Because uncertainty too is sacred. At the edge of all understanding, when we face what cannot yet be explained, we rediscover humility. The same humility that guided the first astronomers, who looked up and wondered what the stars were. Science does not diminish the mystery, it deepens it. Each discovery, each law, each constant leads to another horizon. Even now, cosmologists attempt to bridge this gap, to unite general relativity, the law of the large, with quantum mechanics, the law of the small. Somewhere between them lies the truth of beginnings, the theory of quantum gravity still beyond our reach, waiting to sing the universe's opening notes in a language we have not yet learned to hear. And so we listen. We build telescopes that reach back to the first light detectors, that catch gravitational ripples across billions of light-years instruments, sensitive enough to measure the echo of creation, the cosmic microwave background, the faint afterglow of the universe's first dawn. Through them we glimpse not the beginning itself, but the faint warmth that followed it, like smoke still curling from a distant fire. The question remains suspended in the dark: if time began at the Big Bang, what gave rise to it? The truth may be forever hidden beyond the veil of that first moment. But perhaps that is the beauty of it. Some mysteries are not meant to be solved, but to be lived with, like a melody whose final note we never hear yet, whose music changes us all the same. The universe is not a story with a first page. It is a pattern, continuous, recursive, infinite, in its capacity to reflect itself. What we call the beginning might simply be one of its turning points, a place where equations curve back toward possibility. And as we gaze into that unknowable past, we might realize something profound, that to ask what came before the Big Bang is not to seek a factual timeline, but to engage in an act of cosmic empathy, to wonder what it feels like to be the universe before it knows itself. Perhaps, in some sense, the universe is still learning that lesson, still awakening, still expanding into awareness one mind at a time. And now, as the universe settles once more into quiet balance, may your thoughts drift gently among the stars. Chapter 2. When the math falls silent. For all the brilliance of human thought, for all our equations and telescopes, there remains a place where our greatest theories simply stop speaking. This is the moment when the language of mathematics, that universal poetry of science, begins to stutter and dissolve a horizon, where numbers lose meaning, and the universe refuses to be described. It is the singularity, the point beyond which the laws of physics themselves surrender. The story of this silence begins with Einstein. His general theory of relativity, published in the early 20th century, changed forever the way we think about gravity. No longer a mysterious force pulling on distant masses, gravity became the geometry of space and time itself. A graceful curvature, the universe folding gently around anything with mass. A star, a planet, even you. Bend space-time ever so slightly, as if your presence presses softly against the fabric of existence. The greater the mass, the deeper the curve. Relativity works with astonishing precision. It predicts the orbits of planets, the bending of starlight, and the flow of time near massive objects. It explains why clocks tick slower in the depths of gravity, and why galaxies dance in elegant spirals. But as we wind the cosmic clock backward, letting the universe contract to its earlier states, that same elegance begins to tremble. The equations grow more extreme, the curvature sharper, the density higher, until suddenly the mathematics explodes into infinity. Infinity is not a number. It is the failure of the equation to hold meaning. It is where the story of physics stops being readable. And that is what we call the singularity, the point at which all known laws collapse, and the universe hides its origin behind a curtain of incomprehensibility. Scientists sometimes describe it as a place where the math breaks down, but perhaps that phrase does not do it justice. Imagine it instead as a symphony that rises in pitch, swelling higher and higher, until the notes climb beyond the range of hearing, a crescendo so intense it becomes silence. The singularity is that silence. It is the boundary of thought itself. At this point, even time, that most familiar companion, begins to lose its meaning. We are so accustomed to thinking of time as a river always flowing from past to future. But near the singularity, the river dries up. The very distinction between before and after dissolves. There is no flow, no arrow, no change, only potential. It is not just the end of physics as we know it, but the edge of language itself. And yet this silence is not emptiness. It is density beyond imagining. It is heat so fierce that the concept of temperature itself becomes meaningless. It is the totality of everything, compressed into the smallest conceivable point, a condition known as the Planck's scale, where distances are measured not in miles or inches, but in unimaginable fractions, about 1/10,000,000,000,000,000,000,000th of an inch. Within this realm, quantum uncertainty reigns. Space becomes grainy time, flickers like a candle in wind, and the smooth curves of relativity give way to a foamy chaos of possibility. Physicists call this the quantum foam, the bubbling, jittering structure of spacetime itself at the smallest scales. It is a place not of stillness, but of restless creation, where energy and matter trade, places constantly appearing, and vanishing in an endless dance. This is where the universe, as we understand it, becomes unspeakably strange, and perhaps where it first began. But general relativity cannot describe this realm. Its equations assume space-time is continuous and smooth. Quantum mechanics, on the other hand, assumes it is discrete and uncertain. Between the two lies the great uncharted territory of modern physics, the theory of quantum gravity, still waiting to be discovered. Somewhere in that future understanding lies the answer to what truly happens when the math falls silent. For now, we can only imagine. Perhaps beyond the singularity, the universe contracts not to nothing but to a seed, a region so small and dense that space-time curls back upon itself, avoiding the impossible infinities that haunt our equations. In some models, the singularity is replaced by a bounce, where collapse gives way to expansion, and universes are born from the ashes of their predecessors. In others, it is a horizon of transformation, a boundary where our definitions of time, space, and existence themselves must be rewritten. What we call the Big Bang, then, may not be the beginning of everything, but simply the moment when our mathematics stops breaking, when order emerges from the chaos beneath. The silence of the singularity may not be an end at all, but the pause before a new kind of music begins. Even so, the silence humbles us. It reminds us that for all our precision, our equations are still inventions, exquisite tools built by minds made of the very matter they attempt to describe. When the universe reaches beyond those tools, it is not a failure of understanding, but an invitation to wonder. The physicist John Archibald Wheeler once said, "Black holes teach us that space can be crumpled like a piece of paper. If that is true, then perhaps the beginning of the universe is where that paper was folded into being a crease in the fabric of nothingness, where everything that would ever exist was written in invisible ink." To gaze into that silence is to stand at the edge of knowledge, peering into something that is both deeply scientific and profoundly spiritual. It is to sense the boundaries of comprehension and still feel compelled to reach beyond them. The singularity is the limit, yes, but it is also the promise that there is always something more to learn. And now, as the universe settles once more into quiet balance, may your thoughts drift gently among the stars. Chapter 3. The Birth of Time. Before the first stars flared, before the galaxies spun into being, there was only one event that mattered: the birth of time itself. Not a moment, not an explosion, but a transformation so complete that it defies the words before and after. Time, the gentle river that carries every heartbeat, every sunrise, every breath, did not always flow. It began. It awoke. When we speak of the Big Bang, it's easy to imagine a fireball erupting into pre-existing space. But that image, while vivid, is wrong. There was no space waiting to be filled, no darkness to illuminate. The Big Bang was not an explosion in space. It was the birth of space and time together. The expansion was not something happening inside the universe. It was the universe. Einstein's general relativity taught us that time is not separate from space. It is one of its dimensions bound together into a single entity, spacetime. Imagine a great invisible fabric, smooth yet flexible, curving and stretching under the weight of matter. Planets, stars, galaxies, all press into that fabric, and their presence dictates how time flows. Near a massive object, like a black hole, time slows. In the emptiness between galaxies, it runs fast and free. But in the beginning, at that first instant, there were no galaxies, no stars, no fabric, even to curve. Space-time itself came into being. It is here that we must reshape our intuition. To ask what came before the Big Bang is like asking what lies north of the North Pole. not because the question is foolish, but because before only makes sense once time exists. When cosmologists talk about this, they often say time began with the Big Bang. But what does that mean? It means that every clock that will ever tick, every second that will ever pass, every unfolding of motion and memory, all of it started there. There was no ticking waiting for the event. The event created the ticking. This is perhaps one of the most beautiful and humbling ideas in all of science. The universe did not emerge in time. Time emerged with the universe. Imagine a frozen stillness so complete that even the word still has no meaning. Then, from that silence, something stirs. Not a sound, not a flash, but the possibility of change. That is time's first heartbeat. As space began to expand, time began to move. The two are inseparable. The faster the cosmos stretched, the faster time itself unfolded, sweeping forward like a current. And in that flow, the first laws of physics took shape. The first particles appeared. The first light began to travel. In this newborn universe, the distinction between cause and effect, between what happens and why, was fragile. For a brief sliver of cosmic history, less than a trillionth of a second, reality flickered between chaos and order. Time, newly born, was still finding its direction. It is in this era that one of the great mysteries of modern cosmology appears: the arrow of time. Why does time move only forward? Why do we remember the past but never the future? The answer lies in entropy, the measure of disorder in any system. The universe began in an extraordinarily low entropy state, astonishingly smooth and uniform. From that pristine beginning, entropy could only increase. Disorder would grow, complexity would bloom, and time would find its direction, always moving toward the future, toward higher entropy, toward change. This is why we feel time flowing. It's not an illusion of consciousness, it's the very structure of physics. Every flickering star, every collapsing wave, every dying ember is an echo of that one fact: the universe expanding entropy, rising the river of time, deepening as it flows. But even as time carries everything forward, the equations that govern it are symmetrical. At the most fundamental level in quantum mechanics, in relativity, there is no preferred direction. The math works equally well whether time runs forward or backward. Yet we and everything around us exist only in one direction. This paradox, the asymmetry of time, remains one of the deepest riddles in science. Some physicists suggest that time is not fundamental at all, that it may emerge from something deeper, like temperature emerging from the collective motion of particles. In that view, time is not a property of the universe, but a shadow cast by change itself. It's not that time flows, it's that the universe evolves, and time is how we perceive that evolution. Others, like Stephen Hawking, propose that near the origin time behaved differently, that it might have been imaginary in a mathematical sense, behaving like another dimension of space. In this picture, the universe did not start from a singular point, but from a smooth, rounded geometry, finite, yet without edges. No before, no beginning, only curvature. The surface of a sphere has no start or end. So too, perhaps, the universe. To visualize this is to stand in awe. Imagine walking north until you reach the pole, the top of the world. Beyond that, there is no further north, only south in every direction. The end is not an edge, it's a transition. In the same way, perhaps, time curves gently into being. And what of consciousness? That flicker of awareness that experiences the flow of time. Some theorists whisper that our perception of time may be entangled with entropy, that memory awareness and the direction of time are born together. When the cosmos was young, there was no memory because there was no past. But as time unfolded, so did the possibility of recollection, of difference of history, of experience. In this way, the birth of time was also the birth of potential, the possibility for stars, for life, for thought. The moment time began, the universe began to dream. From this dream, structure rose, space stretched, cooled, and became transparent. Light began its journey, the first photon's flight, across the new expanding cosmos. And as light moved, time moved with it, each second marking the rhythm of creation. To this day, the universe still carries that rhythm, a constant expansion, a gentle unfolding that has continued for nearly 14 billion years. Each passing moment is another ripple from that original awakening. Perhaps that is what we mean when we say the universe is alive. Not conscious in the way we are, but dynamic, unfolding, breathing. Time is its pulse. Space is its body. And we, fleeting luminous beings, are part of its heartbeat. When we look at the night sky, we are not seeing the past. We are seeing time itself stretched across distance. Every star is a clock. Every galaxy a record of a younger universe. The cosmos does not just contain time, it is time made visible. So when we ask what existed before the Big Bang, we are really asking what it means to exist at all. Because existence, as we understand it, depends on time, on change, on sequence, on becoming. And if time itself began at that moment, then the answer is simple, though not easy to accept. There was no before. There was only the readiness for being. Perhaps that is the greatest mystery of all, that from nothing the universe found the courage to begin. And so, in the stillness that follows, we might imagine that first cosmic heartbeat, that first spark of direction, time itself, unfurling like a silk ribbon through the darkness. It is not just a scientific idea, it is a reminder that beginnings are not things we find. They are things we become. And now, as the music fades and the universe breathes quietly, once more we drift toward the next great question. Not how time began, but how far it can reach. And now, as the universe settles once more into quiet balance, may your thoughts drift gently among the stars. Chapter 4. The Edge of Knowing. There comes a point in every journey, scientific, philosophical, or deeply human, where understanding begins to thin like the atmosphere at the edge of the sky. The questions remain, but the answers grow faint, dissolving into the quiet hum of mystery. This is the edge of knowing, where the light of reason meets the vast shadow of the unknown, and where science begins to sound almost like poetry. At the beginning of the universe, we learn to trace the rhythm of expansion, to read the faint fingerprints of ancient light, to map the evolution of galaxies across billions of years. We have measured time itself and folded its story into equations that fit perfectly until they don't. For as precise as our instruments have become, there remains a boundary beyond which they can never see. The cosmic horizon marks the limit of what light has had time to reach us since the birth of the universe. Beyond that horizon, there are galaxies, still invisible worlds, forever hidden, entire realms of spacetime, receding faster than light itself. Not because they are gone, but because they are beyond our ability to know. That boundary is not just physical, it's philosophical. It is where questions, like what lies beyond, or what came before, stop being testable and start being existential. The edge of knowing is the moment when curiosity continues, but knowledge must wait. In that sense, the cosmos mirrors the mind. Both are infinite in potential, but limited in perception. Einstein once said that the most beautiful experience we can have is the mysterious, that it is the fundamental emotion, standing at the cradle of true art and true science. And this precisely is what the edge of knowing offers, not despair at what we cannot reach, but awe that such mysteries exist at all. For when our instruments fall, silent imagination begins to speak. If you could stand at that cosmic horizon, if such a thing were possible, you would see the universe curve away into unknowable distance. The light from far-off galaxies would stretch until it faded into nothingness, its wavelengths elongated beyond detection by the expansion of space. Time itself would seem to slow near that edge, the future pulling away faster than thought could follow. Yet even there, where observation fails, the laws of physics continue to whisper their truths. The cosmos does not need to be seen to exist. It simply is. But there is another kind of horizon, closer and quieter, the horizon of the human mind. For as far as we have traveled in our quest to understand, our thoughts remain bounded by the architecture of our own perception. Our senses evolved for survival, not for cosmology. We can see only a narrow band of light, hear only a fraction of sound, feel only a small portion of the universe's vibrations. The rest, most of it, passes through us unnoticed, like wind through empty space. Yet somehow, we have built machines that extend our reach, telescopes that see beyond the visible detectors, that capture the faint echo of the Big Bang itself, equations that describe the behavior of stars and black holes billions of years away. Even so, there are frontiers we may never cross. What existed before time began? Why does the universe exist at all? Is there an ultimate reality beneath quantum probability, or are randomness and uncertainty the bedrock of being? These questions press against the glass of reason, waiting unanswered. They are not failures of science, they are its future. For every limit we reach expands the map of what remains to be explored. The edge of knowing is not a wall, it is a window, a transparent horizon through which we glimpse both the vastness of the universe and the finitude of ourselves. It reminds us that every answer is temporary, every truth a stepping stone toward a deeper question. The moment we believe we have reached the end of knowledge is the moment curiosity stops breathing. And yet the universe is still expanding. So must our wonder. Consider this: even the cosmic microwave background, that faint afterglow of the universe's birth, carries secrets we have not yet decoded. Its patterns of light, the tiny fluctuations that shaped all structure, still conceal the fingerprints of forces we do not yet understand. Dark matter and dark energy, which together make up more than 95% of the cosmos, remain unseen, unnamed, unexplained. We live surrounded by the invisible, guided by the unknown, and somehow that is enough. Because even without certainty we keep asking, keep reaching. That is what it means to be alive in a thinking universe. In truth, perhaps the universe itself requires this edge of mystery. Without it, existence would be static, a closed system, perfectly known, perfectly finished. But life and knowledge thrive on tension, on the space between question and answer. The unknown is not a void to be feared, but a field to be explored, an invitation written in starlight. To stand at the edge of knowing is to feel both infinitely small and impossibly vast. Small because we realize how limited our perception truly is. Vast because we are part of a consciousness capable of grasping that limitation. No other known being can look at the night sky and recognize its own ignorance as sacred. In that humility lies the true beauty of science. It does not demand certainty, only sincerity. And now, as the universe settles once more into quiet balance, may your thoughts drift gently among the stars. Chapter 5. Time as a breath, the cyclic universe. Imagine the universe not as a straight line from birth to end, but as a circle endlessly expanding, contracting, and beginning again. Time itself moving not forward, but rhythmically, like the inhale and exhale of some vast cosmic breath. This is the vision behind one of the most elegant and haunting ideas in modern cosmology: the cyclic universe. The notion that existence never truly starts or stops, but flows through an eternal sequence of transformations, forever reawakening from its own collapse. The idea is ancient, older than physics itself. Hindu cosmology spoke of vast cycles of creation and destruction, kalpas, where the universe is born, unfolds and dissolves only to emerge anew. The Stoics of Greece imagined a fiery rebirth of the cosmos through ekpyrosis, a periodic conflagration, giving rise to each new age. And now, millennia later, science has returned to that same intuition, this time with equations written in starlight and quantum fields. The story begins where we left it, at the supposed beginning, the Big Bang. But what if that explosion was not a beginning but a rebound? The universe, having once collapsed under its own gravity into infinite density, could have bounced outward again, avoiding a true singularity. This is the Big Bounce hypothesis, and it turns the one-time cosmic birth into a heartbeat of eternity. In this model, the cosmos expands for billions of years, cools, and then reverses its course. Galaxies fall back toward each other, stars burn out space contracts, and the universe returns to an unimaginably dense state. Not an ending, but a poised moment of potential. Then, as though exhaling after a long stillness, it begins again. Every cycle births a new version of reality, perhaps similar to the last, perhaps utterly different. Each expansion is a fresh universe, yet one carrying traces, subtle imprints of the cycles before. Just as a forest regrows differently after each fire, so too might the cosmos evolve through its own memory of form. This idea finds echoes in thermodynamics, in the slow drift of entropy, the measure of disorder in the universe. In our current cycle, entropy is always increasing. Stars burn, their fuel galaxies scatter, systems move toward equilibrium. The arrow of time, that invisible direction we all feel but cannot see, is driven by this relentless increase in entropy. Yet if the universe were to contract again, what would happen to that arrow? Would time reverse, flowing backward toward greater order? Or would a new universe arise with its own arrow, its own sense of before and after, distinct from ours, but born from the same deep rhythm? To think of time this way, not as a straight corridor, but as a breath, is to glimpse a kind of peace woven into the chaos. The universe becomes an organism pulsing with creation and dissolution, endlessly renewing itself. Each epoch a heartbeat, each era a whisper between one expansion and the next. And perhaps this cyclical nature explains the fine-tuned balance of forces we observe today. The gravitational pull of matter, the push of dark energy, the subtle symmetries of quantum fields, all could be the result of cosmic self-regulation perfected over infinite repetitions. What seems improbable in one universe becomes inevitable when universes have been born and reborn forever. There are theories too that blend this cyclic vision with higher dimensional physics, the brain cosmology of string theory. In this picture, our universe is a three-dimensional brain floating in a higher dimensional bulk. Occasionally, this brain collides with another, releasing energy and triggering what we perceive as a Big Bang. Each collision gives rise to a new cycle, a fresh expansion. The rhythm of creation then is written not just in time, but in geometry itself. Two invisible worlds meeting, touching and parting again and again across eternity. It is tempting to think of this scientifically, to focus on equations and evidence on cosmic microwave patterns or gravitational signatures that might confirm the bounce. But beyond the mathematics lies something more profound, an emotional truth, a symmetry that mirrors life itself. Everything we know, stars, cells, thoughts, follows a similar rhythm. We are born, we grow, we fade, and from our matter, something new emerges. The breath of the cosmos is reflected in every living being, every cycle of day and night, every beating heart. The stars themselves participate in this rhythm. Within their blazing cores, hydrogen fuses into helium, helium into heavier elements. When they die, they scatter those elements back into space, enriching the cosmos with the materials for new stars, planets, and eventually life. From death comes rebirth. From collapse, expansion. The same pulse that governs galaxies beats quietly within us. And so, when we imagine the universe expanding and contracting, breathing in and out across eons, it is not just a model of physics. It is a portrait of existence. We too are moments within that breath-brief, luminous exhalations of the universe's ongoing story. If the cyclic model is true, then even the end of everything, the cold, dark, stretched-out fate predicted by entropy, is not the end at all. When the stars fade, when matter decays, when time itself slows towards silence, the universe may draw in its last breath and begin again, perhaps with different constants, new laws, another story. What feels final is only the turning of the circle. This is not speculation meant to comfort. It is the beauty of physics at its most philosophical. Science tells us what is, but it also whispers what could be. And in those possibilities, we find meaning. The cosmos, it seems, does not fear endings, it transforms them. And now, as the universe settles once more into quiet balance, may your thoughts drift gently among the stars. Chapter 6. The Restless Vacuum. For centuries, humanity has described nothing as emptiness, a void, a cold absence of all form, light, and energy. But as we have learned to look deeper, to listen more closely to the universe's hidden pulse, we've discovered that nothingness is not what it seems. In truth, the vacuum, the apparent stillness between the stars, between atoms, between particles, is anything but empty. It is alive with restless motion, humming quietly beneath existence, like a silent ocean of energy. It is here, in this trembling void, that the story of everything may have begun. When physicists speak of the quantum vacuum, they do not mean the absence of all things. They mean a field, a stage, that exists even when all matter and radiation have vanished. In this field, pairs of particles and antiparticles flicker into existence, borrow energy from the void for the briefest moment, then annihilate each other and disappear. These are quantum fluctuations, ephemeral ripples in the energy of space itself. They are not imagination or metaphor, they are measurable, real. Their effects have been observed in experiments like the Casimir effect, where two metal plates placed close together in a vacuum are drawn toward each other, not by any force we can see, but by the subtle pressure of fluctuations in empty space. Even nothing, it seems, pushes back. This invisible activity is not a trivial detail of nature, it is its foundation. According to quantum field theory, every particle, every form of matter and energy is an excitation of an underlying field that fills all of space. Electrons, photons, quarks. They are not separate entities, but vibrations, brief notes played on the grand instrument of the quantum vacuum. And even when those notes are not being played, the instrument itself still hums softly, ceaselessly, forever. Imagine the vacuum not as silence, but as a deep, low resonance that pervades the universe. You cannot hear it, but everything that exists dances to its rhythm. The galaxies, the stars, even your thoughts, all arise as patterns within this underlying music. It is the quiet hum that carries the song of creation. In the early universe, when space itself was a storm of quantum energy, these fluctuations may have done something extraordinary. They may have seeded the inflationary expansion that gave rise to everything we see today. In less than a trillionth of a second, the universe expanded faster than light, stretching those tiny quantum ripples into vast cosmic structures, the seeds of galaxies, clusters, and filaments that now form the great web of the cosmos. What began as microscopic tremors in the vacuum became the architecture of existence. The grandest designs of nature were born from its smallest, most fleeting fluctuations. And so nothing is not empty. It is fertile. It is potential waiting to become. It contains within it the blueprint for everything. Physicists now describe the vacuum as the lowest possible energy state, but even that lowest state is not zero. There is always motion, always vibration, always the whisper of something happening beneath the surface of stillness. This idea challenges the oldest intuitions of philosophy, where once we said nothing comes from nothing. We now see that everything comes from nothing, because the nothing of physics is not an absence, but a presence too subtle for the senses. In its hidden depths, energy and form flicker in and out, testing reality, tasting existence like sparks, trying to remember what fire feels like. Some theories go further, suggesting that our entire universe may have arisen from such a fluctuation that space-time itself is a bubble of quantum energy expanding into the void. If that's true, then we live not in a cosmic machine wound up by divine hands, but in a spontaneous event of pure probability. The universe exists because the laws of physics allow it to, and those laws themselves are woven into the restless vacuum that surrounds us. It is an unsettling thought, and yet deeply poetic, that the universe, in all its splendor and immensity, may be a single shimmering breath of nothingness, learning to be something. To imagine this is to confront a paradox that defines our place in the cosmos. If the vacuum is alive, if even emptiness vibrates with energy, then there is no true stillness anywhere. Every atom in your body, every molecule in the air, is surrounded by this quantum sea. The space between particles is not a void, but a living field throbbing with possibility. The space between stars, between galaxies, between thoughts, all of it alive, with invisible motion. And yet, to us, it feels like silence. Perhaps that is the greatest illusion of all, that quiet means nothing is happening. In truth, even the stillness of the night sky is a symphony too vast and subtle for our senses to perceive. The vacuum is the score upon which reality is written, and the universe is its performance. There is a profound humility in this idea. We who once imagined the universe as a clock wound by gods or destiny now find that it sustains itself. The energy of the vacuum is enough. It is the hidden foundation, the eternal stage, the cosmic fabric upon which every story unfolds. And perhaps this is why the universe continues to expand, why space stretches faster and faster with each passing epoch. The vacuum, with its restless energy, may be pushing the cosmos outward, filling the emptiness with its own invisible force. Physicists call it dark energy, but perhaps that name is too cold for something so graceful. It is not darkness, but balance, the breath beneath the stars. If the cyclic universe is the rhythm of existence, then the quantum vacuum is its melody, soft, endless, and pure. The two together form the heartbeat of creation, expansion and contraction, silence and sound, emptiness and form. The narrator's voice now slows to a murmur, gentle as deep water. There is no such thing as nothing. Even in the void, the universe breathes. Every quiet space between stars is filled with motion. Every shadow carries light unseen. The vacuum is not the end of creation. It is where creation begins again, As the words fade, the image of the cosmos dissolves into a vast dark sea. Ripples of faint light drift outward, vanishing into the infinite. The music fades into a single, low hum, not silence, but the sound of everything that ever was waiting to be born once more. Chapter 7. The Infinite Sea. Eternal inflation and the multiverse. Picture the universe not as a single bubble of space and time, but as a foam of infinite bubbles, each expanding within a greater unseen ocean. Each bubble is a universe with its own stars, laws, and histories drifting apart endlessly in a vast, unseen expanse. This is the vision that arises from one of the most astonishing ideas in modern cosmology: eternal inflation. In the earliest moments after the Big Bang, the universe expanded faster than light 1 billion trillion times in less than a heartbeat. This process, known as cosmic inflation, was driven by an unstable form of energy that filled all of space. As that energy decayed, it released the heat and matter that became our universe. But according to the equations, inflation may never have stopped everywhere at once. In some regions, the energy field continued its runaway expansion, and within that infinite inflationary sea pockets of space, stopped expanding, cooled, and formed new universes. Each universe in this grand model is a bubble in the infinite foam of reality, one bubble among countless others, born not from nothing, but from the decay of that still inflating field. This process, repeating endlessly across eternity, would create not one universe, but a multiverse, an infinite, ever-growing ensemble of universes, each with its own physics, geometry, and destiny. In this view, our universe is both vast and small, a single bubble floating in a sea without shores. The light from distant galaxies may travel for billions of years, but beyond the limits of what we can observe lies a frontier that recedes faster than any signal can ever cross. And beyond that horizon, other universes bloom invisible to us, yet as real as our own. The concept of a multiverse once belonged to the realm of philosophy, of imagination and myth, but now it emerges naturally from the mathematics of inflation itself. The same equations that describe the Big Bang's rapid expansion also allow and even demand eternal repetition. If inflation happens once, it happens forever. It cannot end everywhere. It must continue somewhere. Each spark of decay becomes a new beginning, each bubble a universe unto itself. In our universe, the laws of physics seem finely tuned for life. The strengths of the forces, the masses of particles, the expansion rate, all fall within narrow ranges that allow galaxies, chemistry, and consciousness to exist. Change any of them slightly, and life would be impossible. The multiverse offers a quiet, natural explanation. If there are infinite universes, each with different values of those constants, then somewhere, inevitably, one will have the right combination, not by design, but by the law of large numbers. We find ourselves in such a universe, not because it is special, but because only in such a universe could anyone ask the question. It is an idea that humbles as much as it enlightens. Our cosmos, which once seemed to contain everything, may itself be a single wave on an endless ocean. Each wave unique, yet part of a pattern far larger than any can perceive. Even time, that familiar current, may flow differently in other universes, faster, slower, or perhaps not at all. In one bubble, stars may never form. In another, time may loop endlessly upon itself. The multiverse is not a single story, but an infinite library where every possible version of reality exists somewhere on a page. To imagine this is to stretch the mind beyond comfort into realms where comprehension and wonder blur together. What does it mean if there are countless versions of us scattered across infinite worlds, some nearly identical, others unrecognizably strange? Are we unique, or simply inevitable? If every possible variation of existence unfolds somewhere, then perhaps meaning itself must be drawn not from rarity, but from awareness, the recognition that this particular life, this particular universe, is ours to experience. And yet, for all its strangeness, the idea of eternal inflation carries a quiet elegance. It offers continuity where once there was finality, infinity where there was void. Instead of a single creation, it presents creation as a perpetual act, a breathing, rippling cosmos that never stops giving birth. The multiverse, in this sense, is not a collection of separate worlds, but one vast living process, a single ocean whose waves are universes. Even so, this vision brings its own paradoxes. If there are infinite universes, can they ever interact? Can one bubble touch another? Some physicists believe they can. Collisions between expanding universes might leave traces, faint circular imprints in the cosmic microwave background, like fingerprints left on glass. Others propose that quantum entanglement itself may be the shadow of deeper connections between parallel worlds, thin threads of reality woven together beyond the limits of space and time. But whether we can prove it or not, the multiverse challenges the last comfort of certainty. It asks us to accept that the universe may be larger than our ability to imagine, that even infinity might have layers. To look at the night sky, knowing that it might be only one facet of an infinite jewel, is to feel the true weight of awe, not despair at our smallness, but gratitude for our inclusion in something so boundless. And now, as the universe settles once more into quiet balance, may your thoughts drift gently among the stars. Chapter 8. The Hidden Dimensions. There is a strange beauty in the thought that what we see may not be all that exists, that reality, as familiar and vast as it seems, may be only a thin slice of something deeper. For centuries, we have imagined the universe as three-dimensional space, unfolding through one dimension of time. Yet when physicists began to weave together the forces that govern existence, gravity, electromagnetism, and the quantum fields that shape all matter, the mathematics pointed towards something astonishing. The universe needs more dimensions than we can see. In the framework of string theory, the smallest building blocks of reality are not point-like particles, but tiny vibrating strings, loops of energy whose oscillations determine the properties of everything we know. One vibration becomes an electron, another a photon, another the gravitational pull that binds planets and stars. But the equations only make sense if these strings can move through more than the 4 dimensions of experience. They require 10 or even 11 dimensions of space and time. Where are these hidden dimensions? Why can't we see them? Physicists suggest they may be compactified, curled up so tightly that they exist only on the smallest imaginable scales, smaller than the Planck, length smaller than any instrument could ever detect. Imagine a sheet of paper that appears flat from far away, but has thickness up close. In the same way, each point in space may contain invisible loops of folded geometry, entire directions of reality beyond our reach. These hidden dimensions are not science fiction. They are mathematical necessities, elegant solutions that allow the universe to be self-consistent, balanced, and whole. They might shape the patterns of the fundamental forces, influence the behavior of particles, even determine why our universe has the form it does. It is possible that everything from the curve of space-time to the structure of atoms is a reflection of how these unseen dimensions are folded and arranged. Some models imagine the universe as a vast membrane or brain, floating within a higher dimensional space, called the bulk. In this view, our entire reality, stars, planets, galaxies, even time itself exists on a 3-dimensional surface, suspended within a space of more dimensions. Other brains may float nearby, invisible and unreachable, each one carrying its own universe with its own physical laws. Occasionally, these brains might collide. When they do, the impact could release an immense burst of energy, a big bang giving birth to a new universe. This idea, known as brain cosmology, is one of the most poetic in modern physics. It reimagines the beginning of our universe, not as a singular explosion, but as a collision, a meeting of higher dimensional worlds. Before that collision, there was already structure, already space, already something. The Big Bang was not the start of everything, but the transformation of what came before. And in this higher dimensional landscape, time may not flow as we understand it. The bulk might have its own kind of time, different from ours. Perhaps slower, perhaps cyclical, perhaps entirely outside the sequence of before and after. What we experience as the beginning of the universe could be only a moment within a larger, unseen narrative. If this is true, then our cosmos is not isolated. It is part of a grander geometry, a web of realities, each one born from the motion of hidden dimensions. Even gravity, that most universal of forces, may be a whisper from the bulk leaking across dimensions, explaining why it feels so weak compared to the other forces. The very fabric of our existence may be a shadow cast from a deeper realm. To visualize this, imagine a pond. A stone drops into the water, sending ripples across the surface. We, living on that surface, see only the waves, the expanding circles of motion. But below the surface, unseen, the entire body of water moves. The ripples we observe are merely the echo of deeper currents. In the same way, our universe may be the rippled surface of a multi-dimensional sea. Our entire cosmic history, the shadow of something vaster and more complex. These hidden dimensions are not just mathematical curiosities. They may hold the key to unifying the laws of nature. The dream of physics has always been to find a single framework, a theory of everything, that can describe both the very large and the very small gravity, and quantum mechanics, space, and time. And it may be that those extra dimensions provide the missing link. But this is not merely an intellectual pursuit, it's a philosophical one. Because to imagine hidden dimensions is to challenge the limits of perception. Our senses evolved to navigate the middle scale of existence, the world of trees and rivers, of wind and warmth. Yet beyond that familiar range lies a universe of hidden depth, a cosmos folded into itself, layered like 1,000 veils. We see only what light allows us to see, but reality may be richer, stranger, and more beautiful than we can conceive. Perhaps these hidden dimensions are not truly separate. Perhaps they are woven into the structure of every atom, every particle of light, every pulse of consciousness. The extra dimensions may not be elsewhere. They may be here, folded into the space between thoughts, the silence between moments, the subtle geometries that hold reality together. And now, as the universe settles once more into quiet balance, may your thoughts drift gently among the stars. Chapter 9. The Geometry of Time, Hawking's Imaginary Universe. There is a quiet grace in the realization that perhaps the universe never truly began, that the story of everything has no first page, only an endless circle of existence, turning softly through itself. This was the vision of Stephen Hawking's no-boundary model, a way of seeing the cosmos not as a story with a beginning, but as a shape, smooth, continuous, and whole. In this view, the Big Bang was not the universe's first moment, but a boundary in the geometry of time, a place where our familiar concept of before simply fades from meaning. Hawking proposed that the universe could be finite, yet unbounded, much like the surface of the Earth. You can travel endlessly around the globe without ever encountering an edge or a wall. There is distance, curvature, direction, but no boundary. He imagined time itself behaving in the same way. If we look far enough backward, to the very edge of our understanding, time bends and softens. It becomes not a line that stops, but a circle that closes upon itself. To describe this, Hawking introduced the idea of imaginary time. Not imaginary as in unreal, but in the mathematical sense. Through a process known as a Wick rotation, time is transformed into a quantity that behaves like a spatial dimension. When physicists do this, the equations that once broke down at the Big Bang suddenly become smooth and complete. The singularity, that infinite density where all logic fails, vanishes. The universe seen through this lens has no beginning, no sharp edge, no moment of creation. It is finite, yes, but without boundary. Imagine a sphere. It has surface but no edge, size but no border. The no-boundary proposal suggests that the universe is like that, self-contained, curved through a higher geometry of spacetime, existing without the need for an external cause. In Hawking's universe, asking what came before the Big Bang is like asking what lies north of the North Pole. The question dissolves into the shape of reality itself. In this model, the birth of time is not an explosion, but a transition, a gentle unfolding of geometry. The universe does not emerge from nothing. It arises from the way space-time bends. Time itself is not a separate thread, but one of the coordinates woven into the cosmic fabric. At the deepest level, the universe may be more shape than story, a grand equation describing existence as symmetry and curve rather than cause and effect. It is difficult to imagine such a world, a cosmos, where time behaves like space, where beginnings and endings lose their meaning. Our minds evolved to live in sequence. Dawn follows night, birth precedes death. Yet when we follow the mathematics, we reach a place where these distinctions vanish. The Big Bang is not the first moment. It is simply the point at which time as we know it becomes real, where imaginary time rotates into the temporal flow we experience. Before that, there is no before. There is only geometry. And in that geometry lies peace. No need for infinite regress, no need for a first cause or an external hand. The universe, in its curved perfection, explains itself. It is not suspended in anything, not born from anywhere. It simply is. Just as a circle needs no starting point to exist, so too does the cosmos need no origin to be whole. This vision transforms creation into continuity. It replaces the violence of an explosion with the elegance of unfolding form. The universe seen through imaginary time is eternal, not in duration, but in completeness. Every point is connected. Every moment is part of a greater whole. The very question of why becomes less a demand for cause and more an appreciation of harmony. And yet, within this boundless geometry, there is still mystery. If the universe is a circle without edges, what is its purpose? If time loops smoothly through itself, what role do we brief conscious sparks play in that perfection? Perhaps our awareness is the universe's way of knowing its own shape, of seeing itself reflected in the mirror of thought. Hawking's vision invites not despair, but serenity. It tells us that the universe did not begin. It became. It is not the product of chance or necessity, but of balance. Every atom, every galaxy, every heartbeat is part of the same geometry, a single infinite curve that bends through both space and time. Chapter 10. The Mirror of the Mind. The Simulation Hypothesis. What if the universe, the stars, the atoms, the vast tapestry of space-time, is not what it seems? What if all of it, from the light of galaxies to the quiet pulse of thought, exists within a grand simulation. This is the haunting beauty of the simulation hypothesis. The idea that reality itself might be an intricate code, a pattern so detailed and complete that it feels indistinguishable from truth. The notion began not in fiction, but in philosophy. In the early 2000s, philosopher Nick Bostrom proposed a trilemma, three logical possibilities that seem impossible to escape. The first, every advanced civilization eventually destroys itself before reaching the technological maturity to simulate entire worlds. The second, they survive but choose never to build such simulations. And the third, they do build them. And if they do, then simulated beings unaware of their nature would vastly outnumber real ones. In that case, statistically speaking, it is far more likely that we are among the simulated rather than the simulators. It's an unsettling thought that everything you touch, every breath, every sunrise, might exist as data within some incomprehensible architecture. Yet, as strange as it sounds, the argument is not absurd. The universe, as we understand it, already behaves like a computation. Physical laws are rules, constants are parameters, and the smallest scale of space, the Planck length, might act like the pixel grid of reality. The speed of light could be the maximum rate of information transfer, the cosmic speed limit of a simulated system. Some physicists have even wondered whether traces of this digital scaffolding could be detected. If spacetime were discrete like a lattice, there might be subtle directional biases in high-energy cosmic rays, evidence of a computational resolution. Others have looked to quantum mechanics, where particles seem to exist in a cloud of probabilities until observed. To some, that behavior feels like rendering in a video game. The world only solidifies when the camera turns toward it. But even if we could find proof, what would it mean? Would it change the nature of experience? If the sunset is simulated, does it burn less beautifully? If love is written in code, does it mean less to those who feel it? The answer softly is no. Even a simulated sunset glows with real warmth to those who feel it. Meaning is not diminished by the medium that holds it. A dream can be real while it lasts. Its emotions are true. Its lessons genuine. Perhaps this idea is not so new. Plato once imagined humanity living in a cave, mistaking shadows on the wall for reality. The simulation hypothesis is simply that story retold for the digital age, the cave walls now woven of code and mathematics instead of stone. And just as Plato's prisoners could step into the light, perhaps understanding the simulated nature of reality would not shatter meaning but expand it. If reality is code, then its logic must be breathtakingly elegant. The constants of physics, the fine structure, constant the strength of gravity, the masses of elementary particles, might be the settings of a cosmic program, tuned to allow life to emerge. Within those rules, consciousness arose not as a glitch or side effect, but as the simulation's most profound outcome, a self-aware reflection of the system, looking back at itself. And maybe that is the point. Whether the universe runs on circuits or quantum fields, its purpose could be the same: to generate awareness, to give rise to wonder. If there are simulators beyond our reach, perhaps they too emerge from some other layer, another reality, another simulation. An infinite hall of mirrors, each reflecting the next consciousness, cascading down the line of creation. There is something deeply human about this thought. To ask whether we are real is to feel the ache of curiosity, the same curiosity that has guided us from cave walls to particle accelerators, from firelight to starlight. Even if we were simulations, our capacity for wonder would still be real. Our ability to ask the question is proof that meaning exists, regardless of the substrate it arises from. Imagine the simulators, whether they are beings, algorithms, or something beyond comprehension, watching the unfolding of their creation, would they feel pride, compassion? Would they see us discovering music, love, sorrow, and beauty, and recognize in those moments the echo of their own consciousness? If so, then, creation, no matter its form, becomes a dialogue between the creator and the created, between the code and the dream it generates. And if we are not simulated, if this universe is base reality, the question still enriches us. Because in considering it, we glimpse the scale of possibility. The idea that reality can be both constructed and conscious stretches the boundaries of what it means to exist. The line between physics and philosophy, between fact and feeling, becomes beautifully blurred. Chapter 11. The universe without a before. At the end of all searching there is stillness, the quiet realization that the universe does not need a beginning to be beautiful, nor an ending to be complete. It simply is vast and self-contained, a continuous unfolding of space-time and awareness. The final understanding, whispered softly through centuries of thought, is that there was never a before. The universe is not something that began. It is something that exists eternally, elegantly, perfectly within its own laws. In the great dance between relativity and quantum mechanics, we have searched for the origin of time, for the spark that lit the cosmos. Yet what physics now tells us is both humbling and freeing. Time itself began with the universe. There was no before, because time, the very dimension that allows before and after to exist, was born in the same moment as space. The Big Bang was not a fireball exploding into emptiness, but a transformation, the birth of space-time itself. In its earliest instant, the universe was not expanding into something. It was creating the very stage upon which expansion could occur. When we look backward, tracing the light of ancient galaxies, we approach a boundary, not of matter, but of meaning. Before that first instant, there is no past, not because something hides there, but because there does not exist. Asking what came before the Big Bang is like asking what lies north of the North Pole. The question dissolves, and only the shape of reality remains. This revelation unites every theory, every speculation, Hawking's smooth geometry, the cyclic breath of creation, the quantum foam, the multiverse, into a single truth. Existence is self-contained. The universe does not emerge from outside itself. There is no edge, no external cause. It turns endlessly, like a circle drawn in time, and in that turning, it becomes eternal. To think of time this way is to abandon the comfort of linearity, the sense of beginnings and endings, but it also offers something far greater: peace. If the universe is timeless in its totality, then everything that happens, every star that burns, every life that unfolds, is part of an unbroken pattern. Each event is not fleeting, but woven into the eternal whole. The present moment is not a point moving through time. It is time itself experienced from within. Quantum physics, too, whispers of this truth. At the smallest scales, events do not unfold in strict order. Cause and effect blur, and probabilities shimmer where certainty should be. The passage of time emerges not as a fundamental rule, but as a large-scale illusion, a consequence of entropy and observation. The flow of time, the forward march of existence, may be only the way our consciousness experiences the geometry of the universe. In reality, the cosmos might be timeless every moment, from the birth of galaxies to your next breath, existing simultaneously, already written in the fabric of spacetime. The Big Bang, then, was not the universe beginning. It was the point at which the timeless geometry of existence rotated into what we perceive as time, a seamless transition from possibility to experience. The universe without a before is not a mystery to solve. It is a realization, to accept, and acceptance brings serenity. If the cosmos has no external origin, then it owes its existence to nothing beyond itself. It is complete, balanced, infinite in its own way. Every law of physics, every constant, every delicate ratio is the universe sustaining its own harmony. There is no need for an outside hand or a hidden motive. The equations themselves are enough. They are not cold abstractions, but the purest form of beauty, patterns of logic that sing the world into being. We too are part of that pattern. The atoms in our bodies were forged in stars. The particles within those atoms were born in the first seconds of time. The same geometry that governs galaxies governs the structure of our minds. In this way, the universe knows itself through us. Human curiosity is the cosmos becoming conscious of its own perfection. Every question we ask, every observation we make, every dream of understanding is the universe turning its gaze inward, seeing its own reflection. The narrator's voice grows softer, now the cadence slowing to the rhythm of breath. The universe, it says, does not begin, it simply turns. Every end folds into a beginning, every silence into sound. Time is the circle, not the line. You are part of its turning, a moment of awareness in an eternal motion. As the music swells, the camera drifts outward through the cosmos, galaxies blooming like luminous petals, the great filaments of matter stretching in endless arcs. Then slowly the motion reverses. The galaxies contract, light folds inward, and everything condenses to a single point of radiant stillness, not an ending, but a continuation. The pulse of creation pauses, breathes, and begins again. And in that rhythm, expansion, stillness, renewal, we feel the quiet heart of eternity. The cosmos does not rush, it flows. It does not vanish, it transforms. What was once light becomes dust. What was once dust becomes life. And what was once life becomes light again. Now, as the last starlight fades into the velvet dark, feel how quiet the universe becomes. Beyond every question lies stillness. And within that stillness, a kind of truth that existence has always been complete, always breathing, always returning to itself. Time, matter, thought, and light, all circles within a single infinite rhythm. You are part of that rhythm, a brief but beautiful awareness through which the universe knows itself. The stars above and the neurons within follow the same geometry, the same gentle laws that keep everything turning in balance. Rest in that thought as space drifts into silence. And if your heart feels lighter now, it is because the universe has reminded you there is no before, no after, only now. Only being, only peace. If you enjoy journeys like this, feel free to stay a while. Let curiosity guide your dreams. There's always more to explore softly among the stars.